Okay, so just to give some support on a couple of these problems that I've assigned you for homework, I'll just run through quickly the worked examples. The first one is, what is the pressure of 23 moles of a gas behaving ideally in a quarter of a meter cubed container that's at 310 Kelvin. Well, this is just a fairly straightforward application of the ideal gas law. So you're starting off with PV equals nRT. You're looking for the pressure, so you just rearrange for pressure only. That's given there. They've left the units out here, but everything is fine because they've got the number of moles in moles, obviously. The volume is in cubic meters, and that's down here. And the gas constant is given there, and the temperature is 310 Kelvin. So then they're just not worrying about any of the dimensional analysis, and just giving back the answer is 2.4/10⁵ pascals. So that's a fairly basic application. Hopefully that shouldn't be too difficult. The next one that I'll look at is question 7 here, and I'll explain it, I suppose, in a bit more detail. Okay, so in question 7, it said a fixed mass of an ideal gas has a volume of 23.7 centimeters cubed at 301 Kelvin. If its temperature is then increased to 365 Kelvin at the same pressure, so the pressure remains constant, what will its new volume be, V2? And then part B just asks to explain why the volume has increased. So I've kind of sketched two pictures. First of all, it's important to note that the number of moles is going to stay constant because there's no change to the amount of gas that's actually in the cylinder. The gas constant itself, well, that's a constant as well. That does not change. And the temperature changes, though. That's going to increase. The volume is going to change as well. But the pressure, yeah, that's what they said. It was going to be the same pressure, okay? So the pressure is also going to stay constant, okay? So the technique for this is fairly straightforward. This is actually an application of Charles's law, I think. So you've got PV equals nRT. So what you do is you rearrange everything in terms of the two variables that you're asked about, okay? So you've got volume 1 and temperature 1, and volume 2 and temperature 2. So just explain the theory of where this comes from. If I rearrange everything for V and T, so I'll divide both sides by a T. That gives me temperature on this side, and that gives me N, and I'll divide both sides by pressure. That'll give me pressure underneath the line on this side. Now, if we think about the situation, then in the picture on the left-hand side, the volume, that's volume 1, temperature 1. These are the initial conditions here. We've got 23.7 centimeters cubed and 301 Kelvin. Well, everything on the right-hand side here is constant. So the number of moles is constant, the gas is constant, and the pressure, we're told, is also constant. So because all of this is constant, that means that the ratio of V1 over temperature should be the exact same as V2 over T2, okay? In other words, the volume to temperature ratio should stay the same. So with that, we can substitute in some numbers. And because it's just a ratio, it doesn't really make a difference about the units, so long as the temperature is in Kelvin. Apologies, it does make a difference with the Kelvin, okay? I would not use Celsius because it's totally different. So you've got 301 on this side, Kelvin, equal to V2, and our new temperature is 365. So then just simply rearranging, you get V2 equal to 365 Kelvin times the quantity 23.7 centimeters cubed divided by 301 Kelvin. The kelvins are going to cancel. You're going to be left with a volume in centimeters cubed. So for me, volume number 2 is working out to be 28.7 centimeters cubed. Okay, so that's your new volume. It's increased. So if we go back up to the next part of the question, it says explain why the volume has increased. So I guess there's a couple of ways you can look at that. Because the temperature has increased, in order to maintain the same pressure, remember you've got particles colliding with the walls of the container. So in order to maintain the same pressure, the volume must increase. Okay. So hopefully that makes a bit of sense, and hopefully it's enough to get started with. I'll do another 1 or 2 videos just as a bit of support on this, and hopefully you guys will get on okay with this.